Welcome back to the channel. Before we dive into one of history's most mysterious and cataclysmic events, the Tunguska explosion of 1908, take a moment to like this video, subscribe, and hit the notification bell. This is going to be a long, immersive journey, and you won't want to miss a second. Now, let us transport ourselves over a century ago to the remote, endless wilderness of central Siberia, a land largely untouched by modern civilization, a place where nature holds absolute dominion and human life exists in delicate balance with the forest, rivers, and sky above. Central Siberia is not merely a location. It is a vast, living expanse. Stretching over thousands of kilometers, the boreal forest, or taiga, dominates the landscape. Spruce, larch, and fir trees stand in dense clusters, their trunks rising straight and unwavering, while beneath them the undergrowth, moss, shrubs, and low-lying bushes, forms a thick, soft carpet that can conceal streams, fallen logs, and hidden dangers. Rivers snake like silver threads through this dense green, their waters cold and clear, reflecting the clouds above. In summer, these rivers swell slightly, fed by snowmelt from distant mountains, and their banks become home to a multitude of small creatures, fish, amphibians, and insects, numbering in the thousands. The climate here is harsh and unforgiving. Winters last for months, with snow blanketing the land in deep, unbroken white. Summers are short, often wet, but intensely luminous. The sun barely sets during midsummer, casting a pale golden light over the forest. Nights are long and filled with the strange chorus of Siberian wildlife. Frogs croak from marshes, birds call through the treetops, and insects hum ceaselessly. It is a world of extremes, a place where humans can survive only by understanding, respecting, and adapting to the rhythms of the land. Amid this vast wilderness lived the Evenki people, nomadic or semi-nomadic hunters, trappers, and reindeer herders who had thrived in Siberia for generations. Their knowledge of the land was profound, passed down orally through centuries of careful observation and experience. The Evenki moved with the seasons, following the migration patterns of reindeer, tracking the movements of predators, and fishing in rivers teeming with salmon, pike, and other freshwater species. Their clothing, made from reindeer hide and fur, provided warmth during the cold months, while allowing mobility during hunting excursions. They built conical tents called chum, which were practical for both summer and winter use, easily dismantled and transported as their herds moved. Evenki society was intimate and closely connected to the natural world. Stories, songs, and rituals were not mere entertainment. They were survival guides, tales of spirits inhabiting rivers, forests, and skies informed decisions about hunting and travel. Shamans played vital roles as intermediaries between the spiritual and physical worlds, guiding the community with ritual, prophecy, and observation of natural signs. In this land, the line between the natural and supernatural was thin, and every unusual occurrence could carry both practical and spiritual significance. The terrain itself was challenging. Thick undergrowth and vast swamps made travel on foot difficult. Horses were often used where possible, but even they struggled through marshes and soft soil. Rivers had to be forded or carefully navigated using small wooden rafts. For those unaccustomed to Siberia, each step could conceal hidden dangers: a deep bog, a sudden drop in the riverbed, or a predatory animal lurking in the forest. Yet for the Evenki, this was home. They moved with an ease born of centuries of familiarity, understanding the subtle signs that indicated safety or danger. Despite the wilderness, Siberia was not entirely isolated from the wider world. Occasional trade with Russian settlers occurred, fur was exchanged, and in distant towns, news from Europe or the capital occasionally trickled through. But in the Tunguska region, these interactions were rare. Life followed its own rhythms, shaped by the forest, the rivers, the seasons, and the sky above. It was a life of constant observation, patience, and intimate knowledge of nature. As we imagine this landscape in the early 20th century, it is essential to understand the sense of scale. From a vantage point above, one would see a green ocean of trees, stretching endlessly, broken only by rivers, lakes, and the occasional clearing. To an Evenki hunter, a single day's journey could cover tens of kilometers through terrain that seemed uniform but was actually intricately varied. The quiet was profound, punctuated only by natural sounds: the rustle of leaves, the distant cry of birds, the splash of a fish jumping, or the low murmur of a river flowing over stones. It was a world alive with sound, yet dominated by stillness and patience. Yet this quiet was fragile. In a land so vast and seemingly eternal, forces beyond human understanding could manifest suddenly and violently. The Evenki, with their spiritual framework and intimate knowledge of the land, were aware that nature's balance could be abruptly disrupted. Storms could arise without warning, rivers could flood, and fire could sweep through the forest with terrifying speed. But nothing in their collective memory could prepare them for the unprecedented, otherworldly explosion that would soon erupt in the Tunguska sky. By understanding the environment and the lives of those who inhabited it, we gain context for the Tunguska Event. This was a land of extremes: physical, ecological, and spiritual. A place where survival depended on acute awareness, respect for the land, and adaptability. It was also a place where an extraordinary, once-in-a-lifetime cosmic event could unfold with almost no human warning, reshaping both the landscape and the lives of those who lived there. The year 1908 would bring such an event, one that would become a symbol of the power of the cosmos, the fragility of human perception, and the intersection of science and mystery. As dawn broke over the vast Siberian taiga on June 30th, 1908, the day began as any other for the Evenki and Russian settlers scattered across the region. Birds chirped cautiously in the early morning light. Rivers shimmered under the pale sun, and the forest exhaled the lingering coolness of night. People tended to their routines. Hunters checked snares. Herders guided reindeer along familiar paths, and children played near their village homes, unaware that the sky itself was about to erupt in a manner so extraordinary it would be recorded in history forever. At approximately 7:17 a.m., observers in different locations reported an unusual phenomenon: a bright, fiery object streaking across the sky. Some described it as a massive fireball, luminous enough to rival the sun at dawn, trailing a long blue-white tail that seemed to slice through the Siberian horizon. Others compared it to a glowing second sun that briefly appeared above the forest canopy, casting stark, elongated shadows and bathing the landscape in unnatural light. The brightness was such that witnesses later recounted experiencing temporary blindness or a searing warmth on exposed skin. Dogs barked in panic, birds fell silent or fled, and the very atmosphere seemed charged with anticipation, though no one could understand why. The visual spectacle was accompanied by a sonic shock of unimaginable scale. People reported hearing a series of explosions, unlike any thunder or cannon fire they had ever known. The sound did not travel in a simple, linear way. Instead, it roared across the landscape in rolling waves, knocking people to the ground and shattering windows in villages far from the epicenter. Evenki witnesses later described a feeling akin to the earth itself trembling beneath their feet, a visceral and physical sense that the planet had been momentarily unmoored. Some noted that the air pressure itself seemed to pulse violently, a force that left the strongest men breathless and disoriented. Animals were equally affected. Herds of reindeer scattered in panic, some falling or dying outright from the shock wave. Birds dropped inexplicably from the sky, and fish were later found dead in rivers and streams. The forest, previously a calm and seemingly endless expanse, seemed to quiver as the blast radiated outward, its energy absorbed in every tree, branch, and leaf. Witnesses spoke of spontaneous fires igniting without source, heat intense enough to singe exposed hair and skin, and a strange, lingering smell of ozone and burned vegetation that hung in the air long after the explosions subsided. For those who survived the initial shock, the aftermath presented a landscape almost unrecognizable. The radial pattern of destruction was unmistakable. Trees lay flattened outward from a central point, pointing like spokes on a massive wheel. At the very heart, where the explosion's energy had been most concentrated, many trees remained standing, stripped of branches and bark, charred black, yet still rooted. Streams, rivers, and small lakes reflected an eerie stillness, and wildlife was either dead or displaced. The Evenki described the area as cursed, a place to be avoided for years, imbued with a sense of otherworldly danger that persisted in local memory. Eyewitness accounts, recorded decades later by Leonid Kulik and other investigators, provide some of the most vivid descriptions of the event. One hunter recalled watching the fireball streak across the sky and feeling the air rip through his body as the shockwave passed. Another villager described the sound as 1,000 drums rolling at once, shaking the ground and causing the river to jump as if alive. Children nearby were thrown to the ground by the pressure of the wave, their cries mingling with the roaring, the shattering trees, and the panicked animals fleeing into the forest. Modern estimates suggest that the Tunguska explosion released energy equivalent to 10 to 15 megatons of TNT, hundreds of times more powerful than the largest conventional bombs of the early 20th century, and comparable to some nuclear weapons developed decades later. Despite this, the object exploded in mid-air, several kilometers above the forest, which is why there was no conventional crater. Instead, the energy radiated outward, flattening trees and igniting fires over an area exceeding 2,000 square kilometers. This kind of airburst phenomenon is rare, but it illustrates how a relatively small cosmic object tens of meters in diameter, can produce catastrophic effects without ever striking the ground directly. In the immediate aftermath, locals were bewildered and frightened. Some fled their homes, unsure if more blasts were coming. Fires burned unchecked for days in the remoteness of the forest. Reports of strange atmospheric effects circulated, with skies appearing unusually bright for weeks afterward. Sunsets were tinted deep red and purple, likely caused by fine dust particles lofted into the upper atmosphere by the explosion. These phenomena were recorded far beyond Siberia, demonstrating that the Tunguska event had global atmospheric effects, even though it occurred in one of the most sparsely populated regions on Earth. The combination of visual spectacle, sonic destruction, ecological impact, and human experience makes the Tunguska event unique. It was not merely a meteor strike, it was a complex, multi-sensory disruption of the natural order. To the Evenki, it was a terrifying encounter with a force beyond comprehension. To later scientists, it became a case study in atmospheric physics, celestial mechanics, and planetary defense. And to the rest of the world, it became a cautionary tale. The sky is not static. It is filled with objects moving at immense speeds, capable of delivering sudden and extraordinary destruction. By recounting these moments in painstaking detail, the brightness, the sound, the heat, the trembling earth, the fallen trees, and the fleeing animals, we can begin to appreciate the scale and the drama of that singular morning. The Tunguska event reminds us that the universe is both beautiful and indifferent, that cosmic forces operate on scales that dwarf human perception, and that even in remote, seemingly eternal forests, life is subject to extraordinary vulnerability. After the shock of the explosion had faded into memory, for the Evenki people and distant observers, scientists faced a daunting challenge: how to study and understand an event that had occurred in one of the most remote and inaccessible regions on Earth. The Tunguska event left behind a devastated landscape, a radial pattern of flattened trees, and thousands of square kilometers of altered forest. But no conventional crater, no large fragments of rock, and almost no immediate physical evidence. This absence of a traditional impact site perplexed researchers for decades and led to a series of pioneering investigations that would combine meticulous fieldwork, innovative scientific reasoning, and eventually modern computational modeling. The first major scientific expedition to Tunguska was led by Leonid Kulik in 1927, nearly 20 years after the event. Kulik, a dedicated meteorite researcher, understood that first-hand observation was critical. Traveling hundreds of kilometers from populated areas, he and his team navigated dense forests, treacherous swamps, and mosquito-infested wetlands. Local Evenki guides were indispensable, providing knowledge of terrain, foraging, and survival techniques. Despite the hardships, Kulik documented the radial treefall pattern, mapped the extent of forest destruction, and collected witness testimonies. He also attempted to find meteorite fragments, but these proved elusive. The lack of a large, solid body challenged conventional understanding of impact events, suggesting that a mid-air explosion, rather than a surface collision, might have caused the devastation. Kulik's reports combined qualitative observation with quantitative assessment. He carefully measured tree heights, mapped downed trees, and estimated the energy required to flatten thousands of square kilometers of forest. By comparing the Tunguska blast with known meteorite impacts and explosive forces, he helped establish the concept of an airburst, a cosmic object exploding before reaching the ground. His work laid the groundwork for future scientific exploration and theoretical modeling, even though the expedition could not answer every question. Subsequent research has expanded and refined our understanding of Tunguska. Tree ring studies, for example, revealed anomalies consistent with extreme heat and sudden shock. Trees within a certain radius showed growth disturbances immediately following 1908, indicating intense thermal radiation. Soil analyses detected elevated levels of certain elements, such as nickel and iron, suggesting an extraterrestrial origin. Microscopic glassy spheres, believed to be melted fragments of the object, were identified in various locations. Sediment cores from nearby lakes and bogs further indicated environmental changes consistent with a massive atmospheric explosion, such as increased charcoal layers from fires ignited by thermal radiation. The prevailing scientific explanation, supported by both field data and computer simulations, is that a stony asteroid roughly 50 to 60 meters in diameter entered Earth's atmosphere at high velocity. Atmospheric pressure and friction caused the object to disintegrate several kilometers above the ground, releasing energy equivalent to 10 to 15 megatons of TNT. The airburst generated a shock wave that flattened trees radially, ignited widespread fires, and produced a bright flash observed across Siberia. Simulations of this scenario have closely replicated the observed damage patterns, confirming that the event was not a simple surface impact, but a complex interaction of kinetic energy, atmospheric resistance, and explosive fragmentation. Alternative theories have also been considered. Some researchers propose that a comet, primarily composed of ice and dust, exploded in the atmosphere. This would explain the scarcity of large meteorite fragments, as a largely icy body would vaporize completely upon entry. Other hypotheses have ranged from natural gas explosions to more exotic ideas, including antimatter or mini black holes. While these theories capture the imagination, they lack substantial empirical support. The asteroid airburst remains the most consistent explanation when evaluated against all available evidence. Over the decades, Tunguska has become a test case for planetary defense and near-Earth object monitoring. Researchers have used the event to model the effects of potential future airbursts over populated areas. Simulations calculate energy release, pressure waves, thermal radiation, and ecological consequences, helping scientists assess the risk posed by asteroids of similar size. The Chelyabinsk meteor of 2013, which injured more than 1,000 people and caused widespread damage, reaffirmed the lessons learned from Tunguska. Even small cosmic objects can produce devastating effects if they enter the atmosphere at high velocity. Modern studies have also investigated anomalies in local lakes and soils. One of the most debated is Lake Cheko, located near the presumed epicenter. Some researchers propose that Cheko is a small impact crater from a fragment that survived the airburst, while others argue that its morphology and sediment records indicate a much older origin. High-resolution sonar mapping, bathymetric surveys, and sediment coring continue to provide data, but the question remains unresolved. Such debates highlight the complexity of reconstructing events that occurred in remote, dynamic environments more than a century ago. Satellite imagery, LiDAR mapping, and computer simulations have enhanced understanding of Tunguska in the 21st century. Models incorporate entry angle, velocity, composition, and fragmentation patterns to reproduce observed forest damage. These simulations help researchers predict outcomes of similar future events and develop mitigation strategies. Tunguska is not only a historical curiosity, but also a living laboratory for understanding atmospheric physics, energy transfer, and planetary risk management. In addition to empirical science, the Tunguska event illustrates the interplay between human perception, myth, and observation. Evenki oral histories describe fire from the sky, animals falling from the air, and an earth-shaking roar. These accounts, preserved for decades before the first scientific expeditions, offer invaluable qualitative data. They also underscore the psychological impact of encountering natural phenomena that exceed ordinary experience, revealing how human communities interpret, preserve, and communicate extraordinary events. Ultimately, the scientific legacy of Tunguska spans multiple disciplines: geology, physics, astronomy, ecology, and anthropology. Each field contributes pieces of the puzzle, from analyzing tree rings to modeling asteroid entry, to documenting cultural memory. The combination of remote fieldwork, modern technology, and theoretical modeling has transformed Tunguska from a mysterious anomaly into a well-studied example of a cosmic airburst, a reminder of the immense forces at work beyond Earth's atmosphere and the need for vigilance, preparation, and scientific curiosity. The Tunguska event did not simply leave a mark on the Siberian landscape. It also left a profound imprint on human culture, imagination, and the collective consciousness. While the remote location meant that news of the explosion traveled slowly in 1908, stories of the sky fire eventually reached scientists, journalists, and writers across Europe and beyond. One of the earliest literary responses came from Russian writers, who often blended scientific curiosity with myth and folklore. The image of fire raining from the heavens, toppling trees, and unsettling entire ecosystems resonated with long-standing cultural motifs of divine intervention, cosmic punishment, or natural cataclysm. Later, in the 20th century, Tunguska found its way into science fiction. Writers imagined alien spacecraft, secret weapons, or otherworldly phenomena causing the explosion, blending empirical observation with speculation. The event became a metaphor for humanity's vulnerability in a vast, unpredictable universe, highlighting the tension between human knowledge and the immense forces of nature. In visual media, Tunguska's influence is unmistakable. Films exploring apocalyptic or extraterrestrial scenarios frequently draw inspiration from the event's dramatic imagery. Flattened forests, sudden explosions in the sky, and the eerie, unpopulated Siberian wilderness. Television documentaries, both scientific and dramatized, often recreate the Tunguska morning with meticulous attention to atmospheric detail. The blinding fireball, the rolling shockwave, the panicked animals, and the stunned human witnesses. Video games, particularly in the strategy, survival, and science fiction genres have integrated Tunguska-inspired scenarios, challenging players to survive sudden, devastating environmental catastrophes or to investigate mysterious cosmic phenomena. Beyond literature and entertainment, Tunguska's legacy extends into modern planetary defense. Scientists and policymakers around the world have studied the event to understand the potential threat posed by near-Earth objects. The 20th and 21st centuries saw the development of asteroid detection programs, orbital tracking systems, and impact modeling techniques. Tunguska serves as a historical case study. It demonstrates that even relatively small celestial bodies, tens of meters across, can unleash energy far exceeding the most powerful human-made explosives, potentially threatening populated regions if such an event occurs today. Lessons from Tunguska informed strategies for early detection, deflection, and emergency preparedness, forming an essential foundation for planetary defense initiatives. The Chelyabinsk meteor of 2013, which exploded over central Russia and injured over 1,000 people, reinforced these lessons. Unlike Tunguska, Chelyabinsk occurred near a populated area and produced immediate, tangible damage, mostly from broken windows caused by the shockwave. The similarities in atmospheric entry, energy release, and mid-air explosion highlighted the relevance of Tunguska as a predictive model for cosmic hazards. Scientists used Chelyabinsk to test simulations, validate airburst models, and refine emergency response strategies, demonstrating the continuing importance of studying historic events like Tunguska. Tunguska also shaped public understanding of science and risk. Its combination of mystery, scale, and remoteness made it both terrifying and fascinating. Documentaries and articles often emphasize the human dimension: the Evenki who witnessed the fireball, the herders and villagers who felt the tremors, and the scientists who traveled vast distances to understand the phenomenon. By telling these stories alongside empirical data, communicators bring the event to life, illustrating the intersection of human experience, scientific observation, and cosmic forces. Cultural memory, particularly among the Evenki, preserves a nuanced perspective of Tunguska. Oral histories describe the fire from the sky, animals falling, and the forest's destruction. These stories are not mere exaggerations. They convey ecological observations, atmospheric phenomena, and psychological responses that provide valuable qualitative data. Anthropologists and historians studying these accounts gain insight into the ways human societies interpret extraordinary natural events, blending empirical observation, cultural narrative, and spiritual understanding. Modern technology allows us to visualize Tunguska in unprecedented ways. Satellite imagery reveals the radial patterns of treefall. LiDAR scans penetrate dense forest to map subtle topographical changes, and computer models simulate the energy and trajectory of the asteroid or comet that caused the explosion. By combining historical accounts, ecological data, and physical modeling, scientists can reconstruct the event in remarkable detail. These reconstructions not only satisfy curiosity, but also enhance our ability to prepare for similar events in the future, bridging history, science, and public awareness. Tunguska's influence extends to education and public outreach as well. Planetariums, museums, and science centers often feature exhibits about the event, highlighting both the dramatic narrative and the scientific lessons. Educators use Tunguska to teach concepts in physics, astronomy, environmental science, and risk assessment. By framing the story in both human and scientific terms, these programs inspire curiosity, critical thinking, and an appreciation for the complex interplay between cosmic events and life on Earth. In many ways, Tunguska embodies the intersection of science, mystery, and human experience. It is a case study in atmospheric physics and celestial mechanics, an enduring subject in literature and film, and a practical model for planetary defense. Its story reminds us that our planet exists within a dynamic universe, filled with objects moving at incredible velocities, capable of reshaping landscapes and challenging our assumptions about safety and stability. Tunguska is both a historical event and a living lesson. The sky above is not empty. The universe is active, and human vigilance, imagination, and scientific inquiry remain our best tools for understanding and surviving cosmic hazards. As we look back over the Tunguska event, it becomes clear that this single morning in 1908 was far more than a fleeting cosmic explosion. It was a moment that reshaped landscapes, challenged human understanding, and left an enduring mark on both science and culture. Imagine once more the remote Siberian forest, endless expanses of spruce, larch, and fir stretching to the horizon, rivers winding like silver ribbons through mossy wetlands, and the Evenki people tending to their daily routines in harmony with the land. Then, in a sudden and unheralded burst of energy, the sky ignited. The fireball, brilliant beyond imagination, streaked across the heavens, leaving a long, luminous trail that illuminated the forest in shades of blue and white. Witnesses described an intense heat, enough to singe their skin and hair, and a light so powerful it rivaled the sun itself. Birds fell silent or fled in panic, and animals scattered in confusion. Then came the deafening roar, rolling and multi-layered, shaking the earth beneath the feet of those who dared to remain outdoors. Windows shattered hundreds of kilometers away. Structures trembled. The forest itself seemed to convulse in response to the raw energy released above. The explosion's epicenter, though devoid of a conventional crater, revealed a radial pattern of destruction that bewildered all who later came to study it. Trees lay flattened like matchsticks, pointing outward from the center, while some remained upright, charred and stripped of branches, silent witnesses to the power of the airburst. Rivers and lakes reflected the eerie calm that followed, while fires ignited by thermal radiation burned sporadically across the forest floor. To the Evenki, the area became a haunted and forbidden landscape, a site where nature's laws had been dramatically rewritten, and human comprehension seemed to falter in the face of overwhelming force. Scientific investigation brought further layers of understanding. Leonid Kulik's 1927 expedition mapped the devastated forest, documented witness testimonies, and searched for fragments that might explain the event. Tree ring studies, soil analyses, and microscopic examination of glassy spherules revealed physical evidence of a high-energy explosion consistent with a mid-air asteroid or comet. Modern computer simulations confirm that an object roughly 50 to 60 meters across could release energy equivalent to 10 to 15 megatons of TNT, producing a shock wave capable of flattening thousands of square kilometers of forest without striking the ground directly. Tunguska became the prototype for understanding cosmic airbursts and their potential dangers. The cultural impact is equally profound. Writers, filmmakers, and artists have drawn inspiration from Tunguska's extraordinary imagery and mysterious nature. The narrative of fire from the sky and the sudden silence that followed resonates with human fascination with the unknown. Oral histories preserved by the Evenki offer a poignant glimpse into how communities interpret and survive extraordinary natural phenomena, blending empirical observation with mythology, ritual, and storytelling. Tunguska's narrative bridges science, illustrating the multifaceted ways humanity encounters universe. Modern planetary defense initiatives owe much to the lessons of Tunguska. The Chelyabinsk meteor of 2013 reminded us that mid-air explosions can have serious effects even in populated regions. Detection programs, orbital tracking, deflection strategies, and emergency preparedness plans all take Tunguska as a historical model. Scientists study the physics of atmospheric entry, energy dissipation, and blast propagation to better anticipate and mitigate potential future threats. In this sense, Tunguska is not only a historical curiosity, but a living lesson in cosmic risk management. Reflecting on Tunguska, we see the interplay of awe, fear, and curiosity that defines human experience with the unknown. The event reminds us that the universe is dynamic, sometimes violent, and always beyond complete control.
Our capacity to understand it, document it, and learn from it is a testament to human ingenuity, perseverance, and imagination. Yet it also humbles us, showing that even in the 20th century, with all our technology and knowledge, a small cosmic object could remind the world of forces far greater than ourselves. As we conclude this long journey, it is worth revisiting the essential facts, the human stories, and the scientific insights. The Tunguska explosion of June 30th, 1908 was a singular event. A massive fireball, a rolling shockwave, flattened forests, and fires ignited across a remote Siberian wilderness. It challenged early observers, bewildered scientists for decades, and left an enduring cultural legacy. Its study informs our understanding of planetary risks, atmospheric physics, and the profound ways in which extraordinary events shape human perception. To fully appreciate Tunguska is to engage with both the wonder and the danger of our universe. It is a reminder that the sky is never empty, that cosmic forces can reach out and touch us in ways that are sudden, dramatic, and irreversible. It is a story of nature's immense power, human curiosity, and the enduring quest to comprehend phenomena that exceed ordinary experience. If you have stayed with us through this long exploration, thank you. Your curiosity connects you to the same wonder and amazement that scientists, writers, and observers have felt for over a century. Remember to like this video, subscribe to the channel, and share your thoughts in the comments. Could the Tunguska object have been something other than an asteroid or comet? What lessons do you think modern humanity should take from this event? I read your comments and may feature them in future episodes. Until next time, stay curious and never stop looking up, because the next extraordinary story could be just above our heads, waiting to illuminate the world once more. Let us linger a moment longer on the morning of June 30th, 1908. Imagine standing among the towering larch and spruce trees, the morning mist swirling around your feet. The air is cool and damp, filled with the faint scent of moss and river water. Then suddenly, a streak of fire blazes across the sky, illuminating every branch, every leaf, every creature in stark relief. The forest seems to hold its breath. Birds freeze mid-flight. The water in streams ripples unnaturally. Even the wind seems to pause, as if the entire world recognizes the arrival of something beyond ordinary understanding. Now consider the Evenki who have lived here for generations, reading the sky as their ancestors taught. They understand storms, seasonal patterns, and the behavior of animals, yet nothing prepares them for this. A fire from the heavens, roaring, shaking, and incandescent. Their stories, preserved over decades, describe a profound combination of awe and fear, a mixture that resonates with anyone who has witnessed nature's overwhelming power. It is in these personal human observations that Tunguska's most enduring impact resides, not just in flattened trees or fire-scarred soil, but in the memory and imagination of those who experienced it firsthand. Even today, scientists marvel at the sheer scale of energy released. Computer simulations suggest that if such an object were to explode over a major city, the effects would be catastrophic, with thousands, possibly millions, affected by blast, heat, and atmospheric shock waves. The fact that Tunguska occurred in such a remote location spared humanity from a tragedy of unimaginable proportions. It stands as a warning, a lesson, and an inspiration, a reminder that our planet exists in a universe that is vast, dynamic, and sometimes violent. Finally, as we step back from the trees, from the fireball, from the shock wave and its aftermath, we are left with a sense of scale that is difficult to convey in words alone. Tunguska was not merely an event, it was a reminder of the fragile boundary between civilization and cosmic forces. It teaches us humility, curiosity, and respect for the natural and extraterrestrial world. It encourages scientific inquiry, drives cultural reflection, and inspires imagination. Above all, Tunguska reminds us to look up, to question, and to never assume that our understanding of the universe is complete. The Tunguska event reminds us that the universe is vast, unpredictable, and full of forces far beyond our control. But it also inspires us to observe, learn, and never stop seeking the extraordinary hidden in the skies above.